Ever wondered how a humble potato turns into that crispy golden chip that disappears from the bowl faster than you can say, snack time? Today, we're peeling back the layers, literally, to show you how Lay's potato chips are made, from farm to bag. Lay's isn't just a chip. It's a global snack phenomenon, with billions of bags sold every year, and flavors that range from smoky barbecue to spicy lime. But how do they ensure every chip is paper thin, perfectly crisp, and consistently delicious? To find out, we journey through the fields, the storage cellars, and the ultra-modern Lay's production lines to witness the science and magic behind every bag. The modern potato chip may be a marvel of engineering and flavor science, but its origin is surprisingly simple. In 1853, at a restaurant in Saratoga Springs, a chef named George Crumb sliced potatoes thinner than ever to satisfy a picky customer. He fried them until crisp, added salt, and accidentally created what would become the world's most addictive snack. By the 1930s, potato chips had gone national thanks to improved frying methods and packaging. But it wasn't until Herman Lay founded his company in 1939 that chips became a true American staple. Lay's would go on to dominate the industry, developing its own variety of potato and revolutionizing how chips are made and consumed. Lay's doesn't just buy any potato, they grow their own, literally. Working with specialized farmers across 25-plus U.S. states, they cultivate a patented potato variety, part russet, part Snowden, with 3 key traits: high starch content for that signature crunch, low sugar to prevent browning during frying, thin skins to reduce waste during peeling. These potatoes are so unique, they're protected by U.S. plant patents, and they're grown under strict conditions to ensure every batch meets Lay's standards. In spring, farmers plant these special spuds to take advantage of warm weather and long daylight. Come summer, specialized harvesters dig 10 inches below ground to uproot the mature potatoes, lifting thousands at once along with rocks, soil, and plant debris. High-speed conveyors and vibratory sifters sort through the bounty, processing up to 40,000 potatoes per minute. They're loaded into trucks and sent to enormous climate-controlled storage barns, some capable of holding up to 40 million potatoes. Inside these barns, the potatoes rest at 45 degrees Fahrenheit and 85% humidity. Darkness and cool temperatures keep them dormant, preventing sprouting and preserving quality until it's time to head to the factory. When the factory is ready for a new batch, forklifts transfer wooden crates of potatoes onto a conveyor that drops them into a high-speed water flume. This flume acts like a potato water slide, cleaning, moving, and prepping the spuds for further washing. After several rinsing stages, complete with stiff brushes and powerful water jets, the potatoes are spotless and ready for slicing. They are then trucked directly to the factory floor where things get serious. Upon arrival, random samples are pulled for starch and water ratio testing. A hydrometer is used to ensure the right composition for optimal frying. Another test batch is fried immediately to check for sugar levels, which can cause chips to brown unevenly. Only potatoes that pass both tests move on. Even after all those washes on the farm, Lay's gives every batch one more rinse, a final safeguard before they reach the peeling machines. These industrial peelers, lined with abrasive surfaces and aided by high-pressure water, process over 4 million potatoes per day. After peeling, the potatoes pass under cameras that scan them in milliseconds, removing any spuds with visible flaws or rot. Next, they move across sorting screws that separate them by size. Oversized potatoes are sliced in half for consistency. Each potato enters a spinning drum slicer, where centrifugal force flings them outward against razor-sharp blades. In a matter of seconds, each spud is transformed into 35 paper-thin slices, each about 0.5 millimeters thick. This is the ideal thickness to create that delicate Lay's signature curl. Depending on the chip type, Different blades are used, straight edges for classic, wavy blades for ruffles or wavy lays. Then comes the real transformation. A 40-foot-long continuous fryer filled with a special blend of canola, sunflower, and vegetable oils. The chips cook at 350 degrees Fahrenheit for about 3 minutes, while their moisture evaporates and is replaced by oil, creating that signature crunch. Interestingly, Lay's keeps the oil 50% fresh and 50% used, a balance that prevents greasiness and delivers consistent flavor. Out of the fryer, the chips tumble down gently vibrating conveyors. Why the shaking? Because traditional belts could shatter these delicate slices. Instead, Lay's uses vibration to keep the chips moving without breaking. High-speed cameras scan over 400 chips per second, instantly identifying any dark spots or misshapen chips. Rejected ones are blasted away with targeted air jets into separate bins, likely repurposed as animal feed or compost. Next stop, seasoning. As the chips enter a rotating tumbler, massive 40-pound bags of seasoning mix are added. Either pure salt for classic Lay's or complex spice blends for over 200 global flavors. As the drum spins, seasoning is sprayed evenly, coating both sides of every chip. From fiery jalapeno to smoky bacon grilled cheese, each flavor undergoes strict testing before hitting the shelves. The seasoned chips are lifted to the second floor via bucket elevators, where they enter multi-head digital weighing machines. In just milliseconds, the system calculates the right combo of chip-filled buckets to hit the target weight, whether it's a 1-ounce snack bag or a 13-ounce party pack. Each bag is then flushed with nitrogen gas to prevent oxidation, keeping the chips fresh and crispy. That puff of air you feel when opening a bag? It's nitrogen, also acting as a cushion to protect the chips in transit. The sealed bags are boxed, stacked on pallets by robotic arms and wrapped tightly for shipment. Finally, trucks deliver these golden treasures to stores around the world. From soil to snack in less than 24 hours, Lay's chip journey is a masterclass in speed, precision, and flavor science. So next time you crunch into one, remember, it's not just a chip, it's engineering you can eat. Can you eat just one? Let us know in the comments. And don't forget to subscribe for more behind-the-scenes food factory tours. Ever wondered what goes into that iconic, snappy bite of a hot dog? With over 20 billion consumed annually in the US alone, hot dogs aren't just popular, they're a cultural phenomenon. Today, we'll take you behind the scenes into the high-speed, high-tech world of hot dog manufacturing, where tradition meets industrial precision. From baseball games to backyard barbecues, few foods are as distinctly American as the hot dog. But how does raw meat transform into the familiar frank nestled in a bun? The journey involves specialized ingredients, mechanical artistry, food safety science, and a touch of history. In this video, you'll witness every stage, from sourcing to seasoning, casing to cooking, packaging to perfection. The modern hot dog has its roots in 13th century Europe. Sausage, typically a mix of pork, beef, and spices, is a common staple in cities like Frankfurt and Vienna. When German immigrants arrived in America in the 1800s, they brought this culinary legacy with them. On Coney Island in the late 1800s, Charles Feltman changed everything. He began selling hot sausages inside buns, creating a portable meal that revolutionized American street food. By the early 20th century, the hot dog had become a cultural icon, served at ballparks, fairs, and diners nationwide. Hot dog production begins with meat, traditionally a mix of pork and beef, though modern versions also include chicken, turkey, and even plant-based alternatives. Large industrial suppliers deliver meat in bulk, which then undergoes strict inspection for freshness, safety, and quality. After trimming away unwanted fat or sinew, only the optimal cuts are kept. The exact meat blend determines texture, juiciness, and flavor. Plant-based hot dogs mimic this process with protein isolates, starches, and natural flavoring. The trimmed meat is ground in industrial grinders until it forms a fine paste. This creates the hot dog's smooth consistency. The next step, flavor. Each brand adds a unique blend of seasonings, garlic, coriander, paprika, white pepper, and salt to craft their signature taste. Emulsifiers are added to bind fat, meat, and spices together into a stable mixture. Water or ice is mixed in to maintain low temperatures during blending. This prevents protein breakdown, which could lead to poor texture. Once blended, the meat emulsion is piped into casings. There are two types: cellulose casings, synthetic, used for uniform shape and removed later. Natural casings, made from cleaned animal intestines, preferred for their snap when bitten. Automatic machines fill, twist, and link the sausages in rapid succession. This stage transforms the meat paste into neat rows of hot dogs, ready for cooking. Next comes cooking. Hot dogs are moved through massive steam ovens to ensure they're fully pre-cooked and safe. Some hot dogs are also smoked using hardwoods like hickory or applewood. This adds depth of flavor and creates that subtle, charred note many hot dog lovers crave. In high-end facilities, the smoking process is carefully controlled, monitoring temperature, humidity, and wood type to deliver a consistent flavor profile. After cooking, hot dogs are quickly cooled to prevent bacterial growth. This also firms up the texture. For cellulose-cased hot dogs, the next step is peeling. Using pressurized steam, the synthetic casing is removed, leaving a smooth, polished product. Hot dogs in natural casings retain their skin, offering a more traditional and gourmet feel. Before packaging, hot dogs undergo multiple inspections. Visual checks, texture testing, and even X-ray scans ensure there are no inconsistencies or foreign materials. Any defective hot dogs are discarded or redirected for secondary processing. Brands adhere to strict FDA guidelines and maintain sanitation standards to keep products safe for the public. Once approved, hot dogs are either flash frozen or vacuum sealed, depending on whether they'll be stored or shipped immediately. They're then placed into airtight plastic packages, many of which now include resealable features for consumer convenience. As sustainability becomes more important, companies are also exploring compostable or recyclable packaging options. In today's market, hot dogs come in more varieties than ever. From jalapeno cheddar to cheese-filled franks and even organic and plant-based options, manufacturers continue to innovate. Regional styles like the Chicago dog, Sonoran dog, or Korean-style hot dogs with crispy coatings reflect how this humble sausage continues to evolve across cultures. So, next time you take a bite of a hot dog, whether it's at a picnic, a baseball game, or your kitchen, you're tasting more than just meat and spices. You're tasting centuries of tradition, industrial mastery, and continuous innovation. What's your favorite way to enjoy a hot dog? Classic mustard and ketchup? Or something a little bolder? Let us know in the comments. And if you enjoyed this behind-the-scenes journey, don't forget to like, subscribe, and hit the bell icon for more deep dives into the food you love. See you in the next bite-sized adventure. Have you ever stared at a frozen pizza and thought, how did this perfect circle of crust, sauce, and toppings come to be? Today, We step inside one of the largest frozen pizza factories in the world to uncover how raw ingredients become the cheesy, golden pies that fill grocery freezers. From wheat fields to freezer aisles, this is the incredible journey of the modern frozen pizza. Pizza is more than a meal. It's a global comfort food. And frozen pizza, it's the ultimate convenience. But while tossing one into your oven is simple, the process to get it there is anything but. Behind each boxed pizza lies a highly orchestrated operation, advanced machinery, culinary science, and industrial precision. In this video, you'll see every step that turns basic ingredients into thousands of consistent, delicious pizzas every single hour. The story begins in the flour silos. Towering over the production floor, these stainless steel containers store finely milled, high-gluten wheat flour, chosen specifically for its elasticity and ability to form a chewy yet sturdy crust. The flour is automatically measured and released into mixing tanks, along with water, salt, sugar, and commercial yeast. Timing, temperature, and hydration are monitored by sensors to ensure the dough rises correctly. The mixers are massive, each capable of handling over 500 kilograms of dough per batch. The kneading arms mimic the human motion but at industrial scale, rotating at controlled speeds to develop gluten and air pockets. Once the dough reaches the ideal stretchiness, it's rested in covered troughs for initial fermentation, about 20 to 30 minutes. After resting, the dough is conveyed to a laminator, which rolls it into wide, flat sheets. Industrial rollers flatten the dough to exact millimeter thickness, thicker for deep dish pizzas, thinner for Neapolitan-style crusts. At this stage, cameras scan for air bubbles or uneven edges. Next, a stamping system cuts the dough into rounds, thousands of uniform circles per hour. These discs pass under a docking roller, a spiked drum that gently punctures the surface to prevent puffing during baking. The perforated dough then travels toward the oven. Each crust enters a tunnel oven over 30 meters long, where temperatures reach 400 degrees Celsius. This par bake, or partial baking, sets the outer crust while keeping the inside tender. The timing is precise, usually 60 to 90 seconds, just enough to give the crust a golden hue and slight firmness so it can hold toppings without becoming soggy. Once baked, the crusts enter a chilling section. Cold air at 5 degrees Celsius rapidly reduces the temperature to stop further baking and stabilize the base for assembly. Next comes the sauce station. A large vat of tomato sauce, seasoned with garlic, onion, oregano, and basil, is kept at a controlled temperature to maintain consistency. Each crust moves beneath a rotating nozzle that spirals the sauce in a perfect pattern. The machine knows exactly how much to dispense, avoiding waste while ensuring flavor reaches the edges. Some factories offer multiple sauce bases: Alfredo for white pizzas, spicy arrabbiata for premium lines, or even barbecue for specialty varieties. Mozzarella, often low moisture, part skim, is the star of this step. Cheese is stored in temperature-controlled silos before being shredded into fine ribbons. Conveyor belts carry the cheese to vibrating dispensers that simulate a snowfall over the sauced crusts. Sensors ensure every pizza receives the correct weight, typically between 80 to 120 grams depending on size. For multi-cheese blends like cheddar mozzarella or provolone parmesan, dual hoppers distribute layers in programmed sequences. This is where pizzas get their personality. From classic pepperoni to deluxe veggie to Hawaiian ham and pineapple, the topping line is where culinary meets mechanical precision. Pepperoni is sliced in real time by circular blades, dropping onto pizzas in synchronized rhythm. Sausage crumbles, bell pepper strips, mushrooms, olives, all are dispensed via vibratory trays or robotic arms. Some delicate toppings like arugula or fresh tomato slices may be added manually by trained staff to avoid bruising or improper placement. High-speed cameras monitor topping distribution. If a pizza is missing pepperoni or unevenly loaded, it's automatically rejected and rerouted. Before freezing, each pizza passes multiple inspections. Optical scanners detect anomalies, uneven sauce, misaligned toppings, foreign particles. Temperature probes check crust surface temperature. Random pizzas are pulled and weighed to confirm they fall within legal tolerances. A single missing olive can trigger a rejection in some high-end lines. Human inspectors provide the final say, checking for aesthetic quality and balance. In premium brands, hand-finished touches like extra cheese or seasoning may be added here. From warm assembly to deep chill, the entire pizza enters a cryogenic tunnel, where air chilled to minus 32 degrees Celsius blasts the pie in just 3 to 5 minutes. This ultra-fast freezing locks in texture, flavor, and structure. The cheese doesn't melt, the crust doesn't crack. More importantly, microbial growth is stopped instantly. By the time the pizza exits the tunnel, it's solid as a rock, but looks as fresh as it did 5 minutes earlier. Frozen pizzas are slid into shrink wrap by robotic arms, then heat sealed. Some lines include a cardboard insert or tray for stability, especially for thin crust varieties. After wrapping, pizzas are boxed, labeled, and printed with expiration dates and barcodes. Boxes are stacked in crates and moved to cold storage. Massive freezers kept at minus 20 degrees Celsius until they're loaded onto refrigerated trucks for distribution. From flour to frozen, from tomato fields to your kitchen table, this is how the modern world brings pizza to the people. A dance of steel, fire, and flavor. Next time you bite into a frozen slice, take a second to appreciate the craft and care behind it. If you enjoyed this deep dive into food production, hit that subscribe button and explore more behind-the-scenes stories from the world of industrial kitchens.